And here we're just going to take a look at some more rules that we have working with our trig functions, also bringing in that idea of equation of tangent lines. But first, let's look at those higher order derivatives. So the rule stays the same, that we're just taking the derivative and kind of building on it. So let's say we want to find the first 4 derivatives of y equals sine of x. So that means I'm finding y prime, y double prime, y triple prime, and 4th prime, which usually at 4 we switch over to numerical there and kind of just put it in parentheses. Okay, so derivative of sine of x is cosine of x. Derivative of cosine of x is negative sine of x. Derivative of negative sine x, so the negative keeps hanging out, and the derivative of sine of x is a positive cosine x. And then for the 4th derivative, we'll have a negative, and then derivative of cosine of x is a negative sine x, which simplifies to just positive sine x. So what ended up happening is we went in a loop. After 4 derivatives, you end up back where you started with sine of x. Okay, finding the equation of the tangent line to cotangent of x at x equals pi over 4. So again, with the equation of the tangent line, we're looking for y equals mx plus b. And our first step is going to be to find slope, which is coming from our first derivative at our point, which is pi over 4. So let's start by finding our first derivative. So if f of x is equal to cotangent of x, and we take our first derivative, well, our first derivative is equal to negative cosecant squared of x, and we're going to evaluate this at pi over 4. So we're looking at negative cosecant squared of pi over 4, which is the same as negative 1 over sine squared of pi over 4. And with that, I'm going to go to the unit circle. And we're going to go to pi over 4, which is right here. And our xy coordinate would be root 2 over 2, root 2 over 2. And since we're looking at sine, we want to use the y coordinate, which in this case doesn't particularly matter, but okay, so this is going to be equal to negative 1 over, and then this is sine squared, so I'm going to put that exponent of 2 on the outside there, and then sine of pi over 4 is root 2 over 2. Which is equal to negative 1 over 2/4, which is equal to negative 4 over 2. So we're getting a negative 2 out. So that's our slope of the tangent line. So we're not done yet, but we found we have y equals negative 2x plus b. And what we need is a coordinate to plug in. So we have an x coordinate of pi over 4. We need our y coordinate, which is going to come from evaluating cotangent of pi over 4. So if tangent is sine over cosine, then cotangent is cosine over sine. So we're taking cosine of pi over 4 over sine of pi over 4, which is just going to be a root 2 over 2 divided by root 2 over 2, and we're getting a 1 out. So our y coordinate for cotangent is going to be a 1. So we have a coordinate pi over 4, positive 1, and we're going to plug that in for x and y. So we're going to have y equals negative 2 times pi over 4 plus b. and we're going to solve for b. So 1 is equal to negative pi over 2. Add pi over 2 to both sides, so we're getting a 1 plus pi over 2. Which we could leave it like that. I'll show you two ways to write this answer. So we could write our equation as y equals negative 2x. And then for b, we have this plus 1 plus pi over 2. Another way we could write this is to have b as a single value, which we typically like to have. So what I would do is think of 1 as 2 over 2 plus pi over 2. So b is the equivalent of 2 plus pi as a single numerator over 2. So that more represents it as a single value rather as separated. It's the same thing, but just so you know, and how it will match the answer keys. So negative 2x plus, and then for b, 2 plus pi all over 2. Okay, so our equation of a tangent line, start with that first derivative. We might need some unit circle to help us out, and then plugging in a coordinate. Okay, let's say we want to find the derivative of sine cubed of x. So how we'd want to think of this is as our function sine x quantity cubed. So seeing that through on the outside, then what we can think about is chain rule. So outside function, I have something cubed. Inside function, I have sine of x. So taking the derivative, we're going to take the derivative of the outside, so drop the 3 down, a new exponent of 2, and then we keep the inside. Then we multiply derivative of the inside, so derivative of sine x is cosine x. And then combine it together, so 3 sine squared x times cosine x. And we're all good there. All right, I'm going to go ahead and pause there, and then I'll make a separate video for these next 3 problems.